What's going on, guys? I hope everybody's having a good weekend so far. In this video, I'm going to show you how you can make this death effect. Now, real quick before we get started, this is a different room that I haven't added to the game yet. The entire project is available for download in the description of the video. Just something to note that this room only has a top door and a bottom door, so this will not work with the current map generation algorithm. We're going to cover this in the next video. So if you're following this project series and you download this and you're wondering, like, if you try to go into this room, it's going to give you an error. There's no left and right door, so we're going to handle that in the next video. But in the download, you could get the death effect and you could get this room. I've added a lot of cool stuff, so I don't know if you can see this, but when these little spike thingies hit the wall, they put like this little shockwave. I don't know if you can see that or not in the video, but it really adds a lot. And you can change the shockwave amount and stuff like that. So the next video, we're going to cover making the room. Then after that, we're going to fix the map generation. And then after that, we're going to make these spikes. This video is just going to be the death of our stickman character. So this will work on any character. And you can put this on any character you want. It works best with characters that have multiple objects inside of it. So you can see that my stick wizard has an outer left arm. He's got like his staff, his body, all of the parts of him are all different objects, which makes it so that I can apply a rigid body to all of the sub objects of the character, and it goes everywhere, right? So when he gets hit, you can see that all of his parts go everywhere. And I use cubes for the blood, so I think the blood looks pretty cool. I use cubes to generate that, so instead of just using like a particle, like the normal particle, I don't think the normal particle looks good for blood. And I didn't want to make it realistic because he's a stickman, so I thought that cubed blood would be better. But anyway, the entire project is available for download in the description of the video. And let's do it. All right, so here we are in our heart script. If you recall, in one of the previous videos, we made a static class that handles damaging our player. That way we can call this from any of the other scripts without having to get a reference to this class. So for example, in the spike script that we're going to make in a later video, when it collides with stick wizard, then it can just call heartscript.take damage. Now this kills it. I'm doing 20 damage here because it takes a parameter, which is the damage. So if you get hit by the spike, you die immediately. And I'm a really big fan of games that are like way too hard and you always pretty much lose. So if you're making an easier game, then you could just change this number to something like a lot lower. But I just like killing. If you get hit by a spike in my game, you're just gonna die. That's it. There's no coming back from that. So yeah, so if you take damage and your health is less than or equal to 0 and your state is not already dead, then it's gonna start this coroutine, which is gonna allow you to die. Now, if you can recall, we did this in a previous video, but we're using a coroutine manager to do this because this is a static class. So inside of a static class, you can't call coroutines from a static class because static classes are static. I don't know. Anyway, you can't call coroutines from a static class unless you use a coroutine manager. Basically, this is just because like a coroutine manager is useful like in cases where you're destroying the game object. Maybe it's a spell or something, right? And it hits the wall and it blows up and it gets destroyed. You destroy the game object, or you disable it, or you hide it, or whatever, right? If you destroy or disable the game object, then the coroutine will get disabled because it was attached to the script. But if you start it with the coroutine manager, which is also a static class, which we made this in a previous video, it's like a singleton kind of thing, right? It's not a static class, but it's a static coroutine manager. You can use this to attach it to a game object that you create at the start of the game. That way it's usable from static classes and from objects that are already dead. Like if you destroy the game object, then the coroutine will get destroyed, but if you put it inside of a coroutine manager, it won't. So that's what this is. That we're starting this coroutine called die. Now this is the same coroutine that we already had, but we're passing in this game object, which is our character. Yeah, we're passing in the transform of our stick wizard. And again, we have to look this up because again, it's a static class. So we could pass it as a variable, but I didn't want to do that because then we'd have to put 2 variables in. And when we take damage, it's only going to be our player taking damage ever, right? So you need to write the name of your actual character or whatever here. So whatever the name of your character should go in this slot. And then inside of the die method, this is where we're actually doing this. So the damage panel is just a screen flashing red. So I'm setting that to active, and then I'm deleting the heart panel here. So we're on your screen when you're playing the game, there's hearts in the top left. This just deletes that panel and all the hearts so that you can't see them anymore. We're stopping the playback of the animator. We're setting the state to dead. We're setting the player to be invincible, so nothing else will hit him. Like, we don't want these things to happen multiple times or anything else to hit him. Then we're destroying all of the scripts and stuff that are attached to our player. So this could be unique for your game. So we don't, like, after our player dies, we don't want him to be able to move around anymore. We don't need the outline anymore. We don't need, I mean, actually we're keeping the outline. We didn't delete that, but most of the scripts, you don't want them to be active after your character dies. Because if you're moving around, like if you're still able to move and all of his body pieces are everywhere, then that will look stupid. So this, you have to destroy all of the game objects attached to your player. And then this turns off that red flashing screen. So when you take damage on a game, again, this was covered in a previous video, the whole screen flashes red. This turns that off. This is like a UI panel that covers the whole screen that has like a blood effect on it. And then we're doing this method. This is what makes your character blow up into pieces. So it's a recursive method that takes the transform, which is your player, right? So this is the transform here. And it recursively applies, it recursively goes through all the objects, adds a rigid body, adds a mesh collider, and makes all of the objects fall into pieces. So let's just go through it. So for each child of this parent, so for each item inside of this stick wizard item, it has to skip the death effect because the death effect is all the blood that's coming out. So we don't want the death effect to be moving. If we apply force to the death effect, all of those particles will go shooting off into the side. So we're going to ignore the death effect. And then here I'm ignoring my outer left arm because I'm an idiot. And I put the outer left arm separate from the bone. When I made this in Blender, I did it wrong. I'm going to fix it at a later time. But for right now, if you don't do this, then the outer left arm, because it's separate from the bone, they'll move in different directions and it will stretch the arm. And you'll have this gigantic arm that's going flying, but maybe at the end of the video, I'll show you that. So then we're getting the rigid body of the child component if it already exists. And if it doesn't exist, we're adding a mesh collider to it so that it bounces off the ground instead of falling through the floor. You have to set it to convex because mesh colliders always have to be convex in Unity. I don't know why this isn't the default, but it's not. So you have to set it to convex. And then we're setting the rigid body to be a new rigid body that we're adding. We left the default settings of the rigid body, so we'll have like the default mass and stuff like that. Then we're creating a random force variable. And it's important to note that the y-axis is between 0.5 and 1 and not negative. There's no negative because we don't want it to go downwards. We always want this to go upwards, like flying upwards, because we don't want the parts to go under the ground. And if you shoot it directly straight down, it can sometimes go through the ground. And yeah, we'll just make this a positive only. And then this is the speed of how fast your parts will go flying. So the higher the number, the further your parts will scatter. And then we're adding this force to the object, like the rigid body of the object that we just added the rigid body to. And we're setting it to impulse, so we'll go flying. This forces all of the parts to stay above the ground. So if you go to do this and any of the parts are below the ground, this will set the Y position to 5 of that part. So that way it will teleport above the ground so that none of your body parts go under the ground. And then we're doing this recursively, so it will do the same thing because the stick wizard is the main transform. And then, for example, there's an armature here. Inside of this armature is a bone. Inside of the bone is that. So this will recursively do this until it runs out of like sub objects to go through. So this is what makes your character fall into pieces. And again, this only works if your character is made of multiple objects. So every single piece of my character is a different object. If your character is all one object, this won't work. He'll fall over still, but it won't work the same way. And then we have the effect. So after we're done applying this force, then we find the death effect, which we've attached to our stick wizard character, and we play the visual effect, which is like all of the red squares that are flying everywhere, and we're going to cover that now. Okay, so the first thing you need to do to make the death effect is you need to make sure you have the visual effect graph enabled. So if you go to the window and you go to the package manager in the Unity registry, you can type in the word visual, and there should be an option for the visual effect graph. And just if it's not installed, just click install here. At the very bottom of your project, you just need to right click and create a visual effect visual effect graph. After you do this, you're going to want to drag this onto your character. So you can drag it just like this onto your character. And just drag it right to the top so you can manage it and you can see it better. And then if you go into the scene view and you double click on it, you can see where this is. Now this is the wrong spot. We want this to be directly above our character. So we're just going to reset the transform here on the right. So if you click these 3 dots and click reset, this puts it at the feet of your character. You just want to move it so it's above his head. We're going to use gravity to make it fall downwards. And because it's a top-down game, you could put it inside of him, but I just like having it above his head. After you've done that, then we're going to go through the settings. I'm just going to delete mine. Make sure you name it Death Effect, because in the code we called Death Effect .play. So we're finding Death Effect and we're playing it. So if it's not named Death Effect, it won't work. So let's just go through the settings of it. So let's drag this out like this and we'll go through. So right at the bottom, right at the beginning, let's just set that up first. So we're using an output particle mesh, unlit mesh, instead of the quad. So you need to delete the quad that's there, and if you drag this out, you get a bunch of options here, and you can just choose output particle mesh. It will automatically become unlit once you select the unlit shader graph that we use. So to set the color for this, we had to use a shader graph. You can't just, like, there's not just a color option. It doesn't work like that. So in the mesh slot, you can just, this is just a standard cube. So you could just type in cube here. The cube is part of Unity by default. So it's the one that says Unity Engine Mesh. Don't confuse it with any of these other cubes that are already part of my project. That's just because I named it. It was a cube in Blender before it came whatever it is now. But just choose this one at the very bottom, which is the Unity cube. And then we need to make this shader graph, which is actually what makes it red. So this is how we can control the color of each of our blood particles is a different color. So let me just show you what this looks like. Hang on. So let me press play here and I'll just pause it. So you can see that each of our particles is like a different shade of red. And there's no easy way to do this directly in this. It is easy if you're using an actual particle, but we're not using a particle, we're using a mesh, which is different. And so what we need to do is at the bottom here, if you right click, you can create a shader graph. So shader graph, URP, unlit shader graph, it's this option. And when you open up the shader graph, it will look like this. Okay, and all you have to do is turn off, so turn on supports VFX graph, turn off any type of shadows, so cast shadows and anything else like that, turn that off. Make sure this is unlit and not lit. Lit will make it so that light affects it, and light shining off your blood doesn't look good. And then we're just gonna, if you open up the blackboard with this little clicky thing here, you can add a color property and drag the color into the base color. The properties that are in the blackboard actually show up, so you can see how we have a color option here. Okay, so there's actually some things we have to do before we can do this as well. So this shader graph won't actually appear by default. The shader graph inside of the output particle mesh is actually an experimental feature. So if this doesn't show up for you, you have to go to the edit menu. Okay, so under the edit menu, under preferences, in visual effects, there's an experimental operator blocks option. If you don't turn this on, the shader graph won't appear. So then after you've turned this on, you can click in the drop down and just select the blood shader that you just made. And then after you do that, because color was in the blackboard, it's a property that will show up, right? You can't random this inside of the shader graph, so we're going to use the random features of the VFX graph. There's a random option per particle, which allows us to have a random number for every single particle. And so to add these little things on the side, you just press the spacebar and you can type in random number and then color, right? And so we'll drag the random number into the red value. So to get this red value, it won't be there by default. You have to click this drop down and you can drag it from this random number into the red. It's a number between 0 and 1. If you go above 1, it will start glowing. That's how what's it called, bloom works in Unity. So if you do a number above 1, you can make it glowy if you want to, if that's something that you're into. I don't really like the glow. I just like it like that. And you could also make it so it doesn't go as dark if you want to. So you can make this like 0.5 or something if you want to make it all more red. But yeah, you can just mess around with this however you want. And if you have like a zombie or something like that, maybe you'll have this go to green instead. So So yeah, so like if you have like a zombie or something, you can make this go green if you want to. We don't have a zombie, so we're just gonna leave it red for now. This is our character, but you could reuse this for zombies or all of your enemies or whatever you want to use it. So let's just hit play again. And we'll pause it. Okay, so I'm gonna go through all the settings now. So let's go to the very top of the graph. So this will default to a constant spawn rate. You need to just select it and press the delete key and then press spacebar and just type in the word burst. I'm using a single burst of 1,000 particles. This might be a lot for your computer or your phone or tablet or wherever you're trying to build this for. So just keep that in mind. But the visual effects graph uses the video card by default, which means that 1,000 particles is actually not a lot. You could put 1,000,000 there and it's fine on it depends on your computer, obviously. So make sure that the count is the same as the capacity. It doesn't need to be bigger than that because it's only playing once. Then we're setting the position to a sphere. So like all of the particles are spawning. See this little white sphere? They're all spawning there. And then we're setting the angle to a random angle so that the cubes are not all facing the same exact direction. If you don't do this, you could see that they all spawn. Oh, you're not going to see this anyway because they're rotating over life anyway, but set the angle to 0 at 360 degrees. If you add the set angle node and it doesn't show the random option, on the right here, you can add the random option to per component so that you can randomize. We're getting the current position and then we're multiplying it by -25 and we're doing a multiplication by 25. So the position is where these particles are. So let me just hit play again so we can see this. So when these particles spawn, they're all spawning within this sphere, right? So the position is the distance from the middle of the sphere to where they spawn. So if this is the middle of the sphere, the position is the direction that they're going in, right? So it's like the vector 3 that represents the difference between this spot, the middle spot, and where they actually are. So by getting the position, we can make the particles fly in the direction that they are from the center of the circle. So they will explode into a burst essentially. So then we're multiplying that by -25 and by 25. I think this could actually just be 0, right? I don't know if that's even necessary. So instead you could just put 0 here because you don't need negative. It will just go in the direction. So let's compile this again. Hang on. Yeah, so you don't actually have to put -25. -25 would actually make it go inwards. So like, again, if you have this circle, let me just clear this. Hang on, let me get a new one. So you have this circle. If you do -25, instead of it going this way, the particle will go the opposite direction. It doesn't really matter. It'll still be random, but you'll have particles like going anyway. It doesn't matter. You could just do one of these. So get the position, put it into a multiply, and put that into the second value, and then the first value can be 0, 0, 0. Again, if you don't see the random option like for 2 slots, you can just change that here. So the velocity will be a random between 0 and the position on the sphere, and this is the speed at which it'll go flying away. So if you turn this to higher, like 100 or something, and then you press play, it goes flying way further. So you can just mess with that if you want to. I like 25. We're setting the lifetime to a number between 1 and 5 seconds. That's pretty self-explanatory. We're using gravity to make them fall towards the ground. So then we're using collide with plane. So when you add collide with plane, you have to drag it so that it aligns with your floor, or at least close to the floor. So in my case, that's about here. Now, the cubes don't have they don't have box gliders on them, so make sure it's a little bit above the floor to compensate for the size. Let me just hit play so I can show you what I mean. Hang on. So you see how these are colliding with the plane? If you move this down to the actual floor level, when they collide with the plane, half of the cube could be under the ground, and you can see that. So just make sure that it's above the ground enough to compensate for the size of the cubes. Yeah, and then we're adding the angle, which is what actually makes these spin like this. So they're constantly spinning. So inside of the game view, this just adds to the effect. So while it's playing, you don't have to do this if you don't want to. Let me just see what it looks like when it's playing. Hang on. So let's hit play again and we'll go to the game view. So see how these are kind of spinning as they go off? You could make this a much lower amount. Maybe like 0.1 would be better. And we'll just press play again here. Yeah, that looks better. So just start it to a lower number, but that just makes it spin over time. These cubes won't automatically spin. Like when they hit the ground, it doesn't work like that. They'll just stay the same angle. And if they don't spin, it kind of looks weird. It just looks like they're staying the same direction. I don't know, looks very like staticky, if that makes any sense. And yeah, that's it. And then it goes into the output particle unlit mesh. And then we have a set size over life. So it starts at 0, and then at the middle of this, they become the biggest. And then as they go away, like as they are fading or whatever, then it goes back to 0. So they shrink as they're sliding around the ground. So they start at 0, and then the blood goes like bigger, and then it goes down. So it's just 0 at the start, 1 in the middle, and 0 at the end. So this is the entire effect. So if you do that, the other thing that you need to do is if you click on the death effect, the initial event name is on play. You don't want to leave this enabled because when the game starts, like I'll show you, this will make it play instantly, but he's not dead instantly, right? So you don't want to leave on play. So if you just erase this, it will make it so it doesn't play until it's called. That way you can just leave it. You don't have to instantiate it or anything like that. So yeah, so that's it. And yeah, so we're going to be covering this room and making this room. We're also going to be covering these spikes in a future video where there's like a little shockwave effect happening when it hits the wall. If you guys are enjoying the series so far, make sure you like the video and subscribe to the channel. And if you want, you can leave a comment with anything that you want to learn about in the game. And hopefully I'll see you guys in the next one.